All right. Whoa. All right. I appreciate the hype. First, quickly, I'm Trevor. I'm one of the co-founders here at Split. Split is a feature management and experimentation platform, and I'll let Ariel introduce himself and his quick background.
Hi, and I'm Ariel Perez. I am the VP of Measurement and Experimentation at Split Software. Now, I'd be remiss if I didn't say that my mother would be disappointed if I didn't pronounce my name the right way, so Ariel Perez for those who want to try it that way.
All right, perfect. All right, so we are assuming that you actually understand the concept of feature flags. So I'm not going to dive into that, right? So this is a concept that we're all familiar with, but I am going to quickly take 3 minutes and walk through the journey that we're all on when it comes to feature flags. So first journey is really basic feature flagging, right? We're decoupling releases, we're turning features on or off, right? We're just getting into feature flagging. The second is more advanced, right? We're seeing customers do percentage-based rollouts, turning features on for customers that have a certain attribute or whatever that may be. The third is really starting to bring in data, right? Really trying to think about when I turn that feature on for 10% of my customers, what was the impact on my customer base, right? We're looking to measure, we're looking to learn, and you'll hear some of that from Ariel today. And then we're seeing some organizations that are full-blown experimentation, right? They're writing hypothesis documentation. They're really being critical about why they're building this feature. They're really thinking about, is this working? Is this not working? And as we move towards that experimentation mindset, we're all looking to move to the right? We're all starting basic, getting advanced, bringing in data, trying to become an experimentation-focused team. We need to embrace the challenges that come with experimentation, right? It's about being curious and asking questions. It's about understanding the impact of each of our releases, and you'll hear us talk about some examples and some use cases today. It's about starting small and continuing to iterate, right? It's about trying to do that MVP, getting that capability out, seeing the feedback. It's about staying humble, candidly. You might be wrong. Your assumptions, your hypotheses might be wrong, and so really taking that humble approach. And it's about making sure you're bringing that data, right? That you're letting the data lead you and help you make those decisions. And then the last one is working together as a team, but also working together with your customers and getting that feedback. Now, I talked about this journey, but I thought it'd be good to do a quick stat with you around where our customers are in this journey, right? So not everyone is fully bringing data in, right? And in that experimentation mindset, everyone is at a different stage in this journey. And so when you look across some of our customers, a quick survey, 15% of our customers have some features behind a toggle, right? Not everything, but some are starting to get into the feature flagging landscape. 23% or a quarter have most of their features, right? And a quarter of our customers have most of their features going out behind a feature flag. 8% are actually bringing data in, right? They're starting to understand and monitor and understand the impact. And then over 50% are really starting to run those experiments. They're starting to get to that experimentation mindset. And so asking yourself, where are you in this journey and where are you on your feature flagging journey that we're all on? Now, I am going to turn it over quickly to Ariel, who's going to walk through a few use cases. These will get a little bit more technical, right? So you're going to start to kind of see some use cases that we've run, that we've seen our customers run, and some of the impact of those. So.
Awesome. Thank you, Trevor. I'll just take that from you. So I'm going to be talking a little bit about how you use feature flags and data to monitor impact and use that to actually implement particular strategies when it comes to testing in production. I'm going to talk about two of them. One of them is traffic mirroring. The other one is tap compare testing. And we use those to monitor our rollouts and create zero downtime migrations. So first of all, what is tap compare testing? I'll read right off the slide. So tap compare is a testing technique that allows you to test the behavior and performance of the new service by comparing its results against the old service. So what you're looking here is to make sure that you have parity between the two services and want to make sure that you haven't reverted or regressed when building out the new version of the service. Traffic mirroring is when you deploy a new dark version of an application and copy traffic to it that the current live version is currently receiving. Now, the most important part is that this must be fire and forget to the mirrored instance, because you do not want to impact the running instance. And what you're looking for is errors. You're trying to observe, you're trying to monitor that dark instance in the background. So I'm going to talk about first this particular migration. So we were migrating from Amazon Kinesis to Kafka, and our primary goal here was to reduce the overall cost of our data pipelines. But we wanted to do this migration while meeting the following constraints. We wanted 0 lost events, we wanted no increase in latency, and we wanted no decrease in throughput. And of course, we wanted to do this all with 0 downtime. So we decided to do this via traffic mirroring. This allowed us to compare the costs between the new and the old implementation and validate that the events were being received, and then check that we had no impact on latency and throughput. And all of this with zero downtime. So we're going to start with the current flow. So current flow starts with service A posting an event to Kafka, service B reading the event from Kafka, and then writing that to the data store. And we're going to call this the Kinesis treatment. Then we start building in the Kinesis with mirroring treatment. So it starts the same way. The event still gets posted to Kinesis, and service B reads it and processes it to the data store. Now this is where the traffic mirroring comes in. Remember, I said that you want to make sure it's a fire forget fashion and you do not impact the existing service. So with a try catch, you post the same event over to Kafka. Service B knows that it's reading the event from Kafka, and then a key piece here, fire and forget, it discards that event, knowing that it came from Kafka. So then the last piece of this to close this loop is, you're running this, you're looking for errors, you're looking for issues, you're monitoring in the background, we're looking at the costs, we slowly migrate this and roll it all the way up to 100%. Once we feel comfortable, then we put in the last treatment, the Kafka treatment, and at the end of the day, when service B reads that, writes that to the data store, and just for completeness, we discard any events that we get from Kinesis. So this allows us to run the entire migration and look at the secondary version in the background and understand the impact on costs. Now, talking about latency and throughput, we want to know the exact impact on that. So one of the things that happens is that while service A is posting events to Kafka and Kinesis, has a timestamp, when service B receives those, it figures out basically the latency and how much time it took to go through. So it's going to post an event to Split, and it'll tell Split, hey, this event took this much time. With that, we then create metrics inside Split. We create a latency metric, we create an events per second metric, and we set up monitors to check those and look for any degradations in those particular metrics. And Split will tell you through causal analysis that it knows for a fact that the migration caused this or didn't cause this. And that's the key piece. It's a causal relationship. So the next migration I'm going to talk about is moving from Amazon S3 to MongoDB. And the main reason we wanted to do this is we wanted actually more complex querying. We wanted to do this again, zero downtime. We wanted to reduce latency, and in particular, see if we could increase our write throughput, particularly for updates. So what we decided to do here is tap compare through traffic mirroring, so mixing both strategies. So here we start with service is writing to S3 to begin with. It's writing its events. Then, same as before, with the mirroring, we're writing to S3. And if you remember, try catch is the important piece. Make sure we're not impacting the existing version of the service. And in the try catch statement, now we write to MongoDB as well. And now this is where the tap compare comes in. We read the results from both services, and we have a custom comparison function. And the key thing that comparison function is looking is for material differences. So for example, user IDs you might ignore, timestamps you might ignore. It all really depends on your business logic, but you want to look for material differences. Once you detect the difference, you log that to your logging stack. So you log an event, I found a difference, and you can set up an alert in your monitoring stack and your logging stack saying, hey, I saw at least one event that showed a difference. You can then dig in and figure out where that difference came from. Now, once you figure out that all that works, as before, now you write the S3, the Mongo version, and that last treatment lets you finish the migration and complete that. So now, how do we measure the impact? So remember, there's two flows here. We cared about reads and we cared about writes. The key thing that occurs is that on every write and on every read, we post an event over to Split and tell Split the latency of that event. So now we can create metrics off of that. We can create throughput metrics, we can create read metrics, we can create write metrics, and Split will tell you that it knows for a fact that whether operations per minute went up or down, whether reads got slower or got faster, and whether writes got slower or got faster, and it can tell you that it was definitively caused by the migration. So you know for a fact that your migration to Mongo did improve or degrade these metrics, and that's the key piece here. Using feature flags plus data to be able to get you to a zero downtime migration and make sure you achieve your goals. And that's it. Actually, got through that a lot faster than I thought.
You did. All right.
Awesome. Thank you very much,
Awesome.
everyone.